Bandwidth and latency are two really important concepts to understand in relation to the performance of networks. So let's cover these off. Let's say we have two computers and we want to send data between these two computers. We have a network connection indicated by the blue line. Bandwidth is the rate of data transfer for a fixed period of time. So think about this as the quantity of data you can send in a period of time. So for example, in this case, we could send 1.5 gigabits per second. That's 1.5 gigabits of data for every second. So think of bandwidth as the width of the communication channel. A good analogy to help you understand this is imagine sending water through a hosepipe. Now if you send the water at a specific speed, the width of the hosepipe is going to determine the amount of water you can get through in any specific period of time. If you have a very wide hosepipe and you're sending water at a specific speed, you're going to get more water through it in a certain period of time than you would if it was a very narrow hosepipe. If you have a very wide hosepipe and you're sending that water through, you're going to get much more water than if you have a very narrow hosepipe and you're sending the water through at the same speed. So that's the same with networking technologies. The bandwidth determines how much data we can get through that communication channel in a specific period of time. We then have latency. Now latency is about the distance between our two computers. If these two computers are a long physical distance apart, then it's going to take longer to send that data there. So even if you have a very high bandwidth connection, it's still going to take a certain amount of time from sending that data to receiving that data. And that is the latency or delay on the line. Now, it might seem like that wouldn't be very much, but when you send data from one side of the world to the other over many thousands of kilometers or miles, then that can definitely be a significant latency. Now, whether you're using copper cables or fiber optics, you're actually sending the data at about 70% of the speed of light. So it does move very fast. So over small distances, it's not too much of an issue, but over long distances, it can be. Now, we often measure this in microseconds or milliseconds, more commonly in milliseconds, but there are some applications, some use cases where microsecond latency is very important. So let's look at how you might achieve that. Well, if you have two computers in a data center connected together very close, within meters, then you might get microsecond latency. Or the data centers would have to be extremely close together to be able to send data at microsecond latency between them. But it is possible, and this is sometimes used and required for high-frequency trading applications, for example. In those cases, the traders will lose money if they can't get microsecond latency. Every millisecond of latency that's added can cause issues and mean that they miss out on deals. Now, when we have data centers that are some kilometers or miles apart, then we're talking about milliseconds of latency. And this is typically acceptable for lots of use cases, such as data replication. So when we're building highly available applications that need to replicate data between different sites so that the sites are physically separated from each other, then milliseconds of latency is fine. So it can be tens of milliseconds of latency in some cases, which is acceptable. If we're sending data over much longer distances, so let's say from Australia to North America, now we could have hundreds of milliseconds of latency. Hopefully not, but it's definitely something that you will see on the internet. In that case, we can definitely find problems. Some applications will not work when they're sending data from one application component to another, or when you have replication happening between data sources. Hundreds of milliseconds of latency in many cases is not acceptable for those. Of course, if I browse a website in the US from my browser in Australia, it's pretty much okay. But in some cases, that could be cached locally, or it could just be that the website is optimized. But it's also the fact that it doesn't really matter to me too much if some of the images don't display instantly. Now, with other protocols such as voice over IP, when you're using the internet for sending voice data, then it can be an issue. If you've had a phone call over a long distance using an internet technology and you've had a delay on the line, you probably know how annoying that can be. So voice is definitely much more sensitive. Now, of course, we can't reduce those distances. We still want to be able to talk to people on the other side of the world using voice over IP. But then there are network optimizations that take place. So though I've mentioned distance as being the cause of latency, there are other factors as well. But they're a bit beyond the scope of this course, but they include things like the serialization of the data, the amount of hops, so the amount of network devices that are between you and the destination, and then how network traffic is prioritized, whether it's oversubscribed, whether it's compressed, and various other factors. So there is quite a lot, but the main factor, and the one which I want you to remember for this course, is distance, and distance really is the biggest factor associated with latency. That's it for now. I hope that was useful to you, and I'll see you in the next lesson.